Hello everyone. In this video, I will explain what is the concept of in degree and out degree of a vertex in a graph. So, given a graph, uh, which is in the form of a directed graph, there are two types of edges in that graph. One edge is coming to the vertex, and one edge is going out of the vertex. For example, if you look at this vertex V, some of the edges are going out and some of the edges are coming in. So the edges which are going out will be called as out degree, and the edges which are coming in will be called as in degree. We are trying to understand a problem that given a graph G equal to V comma E stored in the form of a matrix in memory. Okay, we want to find out what is the in degree of a vertex and what is the out degree of a vertex. Maybe the in degree will be the degree uh, representing the number of edges coming into the vertex, and out degree is the number of edges which are going out of the vertex. So, how to find out this in the form of a small idea? This is what is the concept of this video. We have a graph which is already stored in a form of a matrix in the memory. You can see this graph on the screen with edges, and now this graph is stored in the memory in the form of a symmetrical matrix of size 4 by 4 with entries 1 representing age and entries 0 representing there is no age. For example, if I look at this graph, the ages coming out of A are A to B and A to D. So it is 1, 1 here. And ages which is coming into the vertex A is C to A. So from C to A there is 1. Now we want to find out what is the in degree of A, means how many edges are coming to A, and what is out degree of A, means how many edges are going out of A. This basically helps us to understand the density of a vertex. That is how much this vertex is counting in the graph. What is the reliability? What is the dependency of this vertex in the graph? Because if we lose this vertex, how much communication will not be happening in the graph. That is what is the idea behind in degree and out degree. So if I go for a simple concept here, if I sum this row, which is coming for vertex A, then the count of the number values 1 here is 2. And in this way, if I sum everything in the form of row, I get the out degree. Out degree represents row sum. So if I say A going out, sum this and take the value as 2. So out degree of A is 2. And similarly, if I do the column sum, then I get the idea about in degree. For example, the age coming to A is 1, and hence I can say the in degree of A. And then what is the dependency of vertex A? So vertex A has dependency of 3 here, where you can see one is the in degree and two is the out degree. And the sum of the in degree and out degree, uh, if I say sum of the in degree, it is 2, 1, 1, 2, that is 6. And sum of the out degree is also 2, 1, 1, 2, 1, 2, 2, 1, that is 6. So this is a balance property of the graph where we say summation of in degree is equal to summation of out degree. So normally it is not seen. If the graph is balanced, then the in degree sum is equal to out degree. If the graph is not balanced, generally dense for some particular uh, vertex for going out of out traffic and dense for some particular vertex for coming in traffic, then maybe sometimes the in degree is not equal to out degree, but most of the times the in degree of the graph will be equal to the out degree of the graph, that is equal to 6, and this gives you the dependency of the vertex. So a vertex may have generally may have different in degree and out degree, but generally the balanced graph will have summation of in degree equal to summation of out degree. Hope you understand this idea. The major takeaway is just sum the row in the matrix to get the out degree, and just sum the column in the matrix to get the in degree. Thank you very much.